slide says that your presenter today is Tony Andrews, and that is false. So Tony was going to do this webinar, and Tony got caught up in some travel issues. He was on the road yesterday teaching a class, and as often happens with travel, was held up. So he asked me to step in. So the webinar topic was, some of Tony's top SQL enhancements in DB2 from version 9 and onward. And when he handed me the slide deck last night, he had 72 slides of Tony's favorite things about new SQL features. So I adjusted the title slide a little bit. And number one, I pared the 72 slides down to something that we could do in 45 minutes here. And I also renamed it Dave's favorite of Tony's top DB2 SQL enhancements. So if you did a Venn diagram of Tony's favorite things and Dave's favorite things from the last several releases of DB2, that's what this presentation is going to be. So perhaps we'll have Tony come back in a couple months and do a webinar of the other things that Dave left out. So anyway, welcome. And there's some really great stuff in here, some great SQL examples that you'll hopefully be able to use in your everyday life. And that's kind of where we're going with this. My email address is on the title slide here, dsimpson@themusinc.com. Tony's email was on the other cover. Maybe I should just have you direct your questions to him, tandrews@themusinc.com. Tony and I have always thought of ourselves as basically interchangeable. We do an awful lot of the same topics. So really either one of us should be able to help you. And if it's something that the other one is an expert on, we typically will forward those things to each other. You can also follow Themis, our company, on the Twitter at Themis Training, where you'll see announcements of future webinars and classes and stuff. So the brief word from the sponsor is that Tony and I both work for a company called Themis. We do training both on-site with our clients and publicly. Our public schedule is available at the website themusinc.com. And obviously one of the things that we're hoping to do by doing these webinars is convince you that we're pretty good at meeting your training needs. So take a look at the website. Pretty full curriculum out there in DB2 and a lot of other things. And we'd love to be considered for your company's training needs. And if you have any questions about what we can or are able to do, you can feel free to drop me an email offline. Another thing, it's on the slide coming up here, I think. Right down there at the bottom of this one, if you would like a copy of today's slides, you can get them. themusinc.com/webinars. You should see right at the top right now of the page, so something like today's webinar and a button that says get the slides. So if you'd like your very own copy of what you're seeing on the screen, just run out to the website and grab them. The playbacks for a bunch of historical webinars are out there as well. I realize the last couple videos are actually not available yet, and I'm actually working on the post-production for those today and tomorrow. So hopefully by tomorrow we'll be caught up and you'll be able to see the playbacks from pretty much all the webinars we've ever done, along with the playback for today. So if you have colleagues that you think would benefit from what we talk about today and they weren't able to attend, keep your eyes open on that site, and we'll try to get to them. There is a question box in the GoToWebinar box that's probably on your screen right now. You can feel free to put questions in there. If we have time, we'll try and get to some of those at the end. And we'll, if not, you can always shoot questions via email. We try and answer all of those. Please use either Tony's email address or mine. Don't reply to the one that sent you this webinar invite, as that's not a monitored box. All right, so what are we going to be talking about today? Well, again, this is Tony's favorite and Dave's favorite SQL things from about version 9 to version 12 of DB2. So what I find a lot is there's people still coding SQL like it existed 20 years ago. The SQL features, the new features, have been kind of trickling into DB2 over the last several releases. And if you go back to about the version 8 or 9 timeframe, the new releases typically have lots and lots of stuff for the DBAs in terms of how they create tables, particularly how they create table spaces, options they have on indexing, options they have on utilities. And there's always SQL stuff in there as well. But every once in a while, it's good to kind of step back and say, for the developer, you know, what has changed over the last 10 years? And that's kind of what we're trying to embody here. So I'll give you just some highlights of some of our favorite stuff. The next several pages, Tony kind of listed out, you know, here's what we liked in version 8. Here was the SQL stuff from version 8. You know, here's the SQL stuff from version 9, and more version 9, version 10, version 11, and eventually version 12. If you ask me to talk about all the, you know, SQL stuff that came in version 12, you know, I can spend the better part of a day on that. So again, we're going to try and hit some highlights here, and I imagine that in an audience like this, about half of my clients are now still on version 11 of DB2. The other half are in the process of migrating to version 12. If you're still on version 11, hopefully your DBAs and system folks are in the process. And I'm talking DB2 for ZOS here. If we have DB2 LUW people on the line, and we always do, the version numbers may not line up on all of this stuff the way, because we've kind of written it for DB2 for ZOS. But all of this stuff works on DB2 LUW. It's just you may have gotten it in a different release. Okay, so we'll hit the highlights of some of this, and again, Tony will hopefully be back in another webinar or so to cover the additional slides that I paired out just for time's sake. So we'll start with the merge statement. The merge statement was introduced in version 9 of DB2, and for those of you DB2 ZOS people, it got greatly enhanced in version 12. The concept of the merge is, well, the original way that they did it on DB2 was basically what I refer to as an upsert. So in this case, I've got a table called item on line 1 there, and I'm got a set of values for a potential new row, or maybe it's not a new row and I just want to update it. So in other words, I've got an item number 1, its item name is widget. If there's already an item number 1 on the table, I want to make sure that its description is widget. And if there's not already an item 1 on the table, then I want to insert it. And this is how they, this is ANSI standard SQL right here. Supported on most platforms that I've encountered, you can do this. Basically, those first 3 lines say, I'm making a new little fake table called new item. And it's got 2 columns, item number and item name. And the value for item number is 1, and the value for item name is widget. So it's a little 1-row table. line number 4 there on I.item number equals new item.item number, I'm saying I'm actually going to take this little fake table and join it to the real table called item. And that on clause may look an awful lot like a join predicate, like you would write if you were joining two tables together. And in fact, you are joining two tables together in this example. I.item number equals new item.item number. And then there's two possible outcomes of that join. I either found a match or I didn't find a match. Right? And so I say when matched. In other words, when I found the row where I.item number is equal to 1 in this case, right? Then I'm going to update the item table and set the values for the other columns. In this case, there's only one other column. And when not matched, I'm going to do an insert. And if you examine that update and insert statement fairly closely, you'll notice they're not like fully formed update and insert statements. For example, neither of them mentions a table. Right? Which table am I updating? If I find a match, well, I'm updating the item table. Same with the insert. You can't just put any SQL that you want in there. It has to. You can only reference the table being referenced in the merge back up on line 1. Okay. On the update, also, you don't have a where clause, which would normally be considered a problem on an update statement. Here I'm updating only the row or rows that matched. Right. So this has been around since about version 9. This kind of row by row update. It has a reputation for not being a terribly good performing statement. I mentioned you're doing a join, right? So if you did a straight up insert or a straight up update here, you wouldn't have to join the two tables together first. So I think it's safe to say that the merge statement as written here will not perform as well as either the standalone update or the standalone insert. It may outperform the rest of the logic you would have to do to figure out whether or not to do an insert or an update, though, right? And if I have a bunch of developers in a room, I can usually get a pretty good discussion going about whether or not or how I would code this without the merge, right? Some people will say, well, you should select the row first to see if it's there. And other people will say, why don't you just blindly try the update? And if it gets an SQL code 100, then do the insert. The merge is probably going to outperform that whole mess, right? Now, the one exception here is suppose you have a situation where, like 80 to 90% of the time, you're going to be doing an update, right? The row is already there. Well, in that case, it's probably better just to try the update, right? Just blindly try the update. If 80 to 90% of the time it's going to work, then spend a few extra cycles failing over to the insert when it doesn't. But if it's really going to be 50-50, or you just don't know, one SQL statement is typically better than two. Although this is going to be, a rather expensive statement. All right. When the merge statement was invented, I don't think that is what the inventors had in mind. What they had in mind was more the ability to merge two tables together, to take the rows in one table and merge them into a second table. And that is what the version 12 enhancement to merge does or allows for with a bunch of things that we couldn't do before. So this enhancement, if you're DB2 ZOS, you only get if you are version 12, I guess what I'll call new function mode, which is, for those of you familiar with the continuous delivery paradigm, V12, R1, M500 or greater. Sidebar, we're starting a whole series of webinars next month with Linda Clausen and myself. We're going to alternate where we talk about the continuous delivery of new functionality into version 12. So if you are coming up on version 12 and you're trying to figure out how that migration should work, or if you want to understand how new functionality is going to be delivered to you, I believe the first installment of that is in mid-September. So you can check it out on the webinars page of our website. So I do have to be, at least on the very first level of new functionality in version 12 in order to get this. You'll see that using block, so lines 2, 3, and 4 there, instead of listing a set of values for a potential row, here I'm listing a subselect. Okay. Now, in this case, I'm not merging two tables together. I'm actually kind of merging or dealing with rows on a single table. So I'm merging into emp and I'm selecting from emp. Okay. Got a lot of flexibility here, but I think the more standard sample would be I have two tables that kind of look alike that have different sets of rows with maybe some overlap, and I want to take the rows from the first table and merge them into the second. And if I find the row already there, I want to update it. If I don't find the row there, I want to insert it. Or we have some other options now. So first of all, the list of values is replaced by a subselect. We still have an on clause that tells me how do I decide whether a row is already there or not. And then the other new functionality I have in version 12, you can see on that first when clause, when matched and the salary is greater than or equal to 50,000, you can have multiple when matched, with additional predicates there. Okay, so when I find a match and the salary is greater than 50,000, then it looks like I'm going to give the person a 500% raise. That's kind of nice. When I find a match and the salary is less than 40,000, then you're fired, I guess. So that's a new thing as well, right? The ability to actually delete rows that I match to. Okay, so you can actually take values from the first table and use them to delete rows on the target table. That delete on the second when clause is about the simplest statement you'll ever find, right? Which table am I deleting from in a merge statement? Well, you can only modify rows from the table listed up top here, right? So I'm deleting from the emp table. That's implied. Which row or rows am I deleting? I'm deleting the rows that matched from the subquery and had salaries of less than 40,000. Okay. And again, that's implied because those are the rows that made it into this part of the query. When matched and salary is less than 50,000, then they get a 10% raise, it looks like. Now, there's something important to note here too, right? These are not necessarily mutually exclusive, right? If my salary is less than 40,000, it's also less than 50,000, which makes up the last two when clauses. But it's going to hit the first one that it meets the criteria for. So in other words, if I'm less than 40,000, I'm going to hit the first one and be deleted. So what you're really seeing there is I must be greater than or equal to 40,000 and less than 50,000 to hit the last update. Else ignore. In other words, don't do anything if I don't meet any of those criteria, or if I don't find a match at all. All right, so we have the ability for much more complex when logic in the version 12 merge, and that ability to stick a subquery up in the using is kind of the original purpose of the merge. And the example we've got here is a little bit unusual in that both the source and the target are the same table. Probably a more common use would be I've got two tables that look the same that maybe have different data, and I want to merge the rows together. But you can do all kinds of interesting things with it, as you can see here. Okay. Here's an example where we're merging into an emp project table, and the source is the emp table. Okay, still have the on clause. When matched and the salary is greater than 50,000, then I'm setting the time on the target table. When matched and less than 40,000, I'm still deleting the row. When not matched, then I'm inserting it. And when I do an insert here, I can use values from the source subquery. So this whole thing up here is called E, right? E.empno is coming from there, and I can also hard code things if I would like. Right. Again, lots of flexibility in the merge. The merge as it came in version 9 was not terribly flexible. As it's updated in version 12, it is pretty flexible. And they've also along the way solved some of the performance issues that people have had with the merge over the years. Okay, so it performs better both internally and externally in terms of what I can do. Okay. A related feature, and we're going to come back to the merge in just a second. This came all the way back in versions 8 and 9. It was delivered in a couple of phases. But the idea that when I do an insert sometimes, or any kind of data modification, sometimes there are things that happen that I want to know about that I don't know about before they happen. That's a long way of saying, you know, in this example, I'm using a sequence to supply the primary key for a new customer. So I'm inserting into the customer table, and the customer number is going to be supplied by a sequence. Well, it may be important for me, you know, in the next statement in my program to know what just happened, right? What's the customer number for this new customer I just inserted? I don't know it before the insert, and the insert itself doesn't tell me what it was. It just says SQL code 100, I inserted a customer. And again, in the old days, I would have to select the row back then to find out what did I just do. So in version 8, and again, enhanced in version 9, they gave us this ability to select from the results of a data modification like insert. So here you see I'm selecting customer number from final table and then wrapping that insert in parentheses. So the primary thing that happens here is that we're doing an insert, but then the select allows me to receive back into my program some of the values that I just inserted. Now, for most of these, like my customer name and my location and whatever else I've got going on, there would be no reason to select them back, right? Because I knew what they were when I did the insert. But things like sequences or identity columns or current date, current timestamp, where you're asking the system to supply the value, you can use this neat little feature to get the value back. Okay, so in this case, I'm getting back the customer number that happened as part of the insert or was generated for me. This could be true also with an identity column. So the previous example showed a sequence, right? This is an identity column where the way we do the insert here is we just ignore the customer number, right? And it's going to be automatically inserted. So my insert here makes no mention of customer number, but that doesn't preclude me from selecting it back. So at the bottom example there, I'm selecting customer number even though I didn't mention it in the insert. And that works out great. Okay. A quick note about that thing called final table. Final table is kind of a placeholder in the from clause. There's actually two things you could put there. You could either say final table or old table. If I'm selecting from an insert, it's always going to be final table. The idea is final table represents the row after the operation has occurred. And old table would represent it from before the operation occurred. If I'm doing a select from an insert, there is no old table. Right? There's no before picture of a row that's being inserted. If I was doing a select from a delete, and that's possible too, right? You can say delete from table, and then I want to select the rows that I just deleted. You can do that, but you're going to say select from old table. In other words, there's no after picture of a deleted row. There's only before. And if you do a select from an update, you can do either one. Show me the before or after picture. Okay, we don't have examples of those, but they're pretty easy to invent. Okay, now one of the things we can do, and is sort of important when you consider the merge, is a select from the merge. And in the merge, you can only use final table, although at least conceptually it makes sense to me that we should be able to use old table, because sometimes we're doing an update or delete. But there's only final table available on the merge. And one of the things we can use this for is to answer what seems to be the pervasive question about merge. How do I know whether or not I did an insert or an update. All right, so this is back to the very first example we did with a merge, where we have our item table and we're merging a value in. When you come back from this, DB2 will say SQL code 0, I did it. And if you're even more thorough, you can interrogate SQL error D occurrence 3, and it'll say I affected one row. But what you don't know is whether that one row was an insert or an update. So if you really need to know whether you did an insert or an update, because you're keeping counters or some other important thing like that, you can actually do a select from the merge from final table. And line number 3 there is an include column. An include column is sort of like you're saying, hey, let's pretend the item table has this extra column on it that isn't really there. For purposes of this statement only, item table has this extra column. It's called update indicator and it's char 1. You can call it whatever you want. Its data type could be whatever makes sense to you. But then you see, when we get down into the insert or the update, you can refer to it as if it's on the item table. So if I get down to the update, I'm saying, hey, set that update indicator equal to a U. Or if I get down into the insert logic, set the update indicator equal to an I. And then notice what I did. I said select from final table, and I selected the item name along with that update indicator. So in this case, I see a U there, which indicates to me that this row was already there. Right? And I have updated the item's name, and you see the indicator that tells you that. This update indicator goes away as soon as the statement ends. Right? It's not real. It doesn't persist. We're just kind of tacking it onto the table logically for purposes of this statement only. So this is a very common question that gets asked about the merge statement. How do I know what I did? This is the technique that you can use to determine what was inserted and what was updated. All right, so sticking with version 9 functionality here for another minute. The functions that we're about to talk about are collectively referred to as OLAP specification. OLAP more generally stands for online analytical processing, right? So OLTP is transactional stuff. OLAP is more analytical stuff. So these functions are, I suppose, going to be most commonly used with analytics or those kind of things. And they give you the ability to rank things. All right, so here I'm working with my little good old sample table from IBM. And I say I want to rank people by their salary. Right? Select rank over order by salary descending. Now, all of that on the second line is going to be that one column in my result, the rank, we're calling it R. So the rank function itself doesn't take in any arguments, just open close paren, but it expects this modifier called over, and in the over clause, there's two things you can put in there. The one that's required is order by, and we'll see a partition by in a moment. But order by salary descending says, how do I want the ordering, right? Who gets the highest rank? And because we've said order by salary descending, the person number 1, rank number 1, is going to be the person with the highest salary, salary descending. We're highlighting here too what the rank function does when you hit ties. So Heminger and Lucchesi had a tie at number 2. The rank function specifies that they're both number 2. And then we skip number 3 because we had a tie at 2, and Thompson is number 4. Okay. A quick word about the order by, and we don't have an example in these slides, but you can have a final order by there, and you probably should. If you want them in the order that you're seeing here, you should probably also say, after the from clause, order by salary descending. right? Get them in the same order as you ranked them. But you actually don't have to. I could say order by last name, right? And then you'll see them in a different order. The order by in the rank function controls how the numbers are assigned. The order by at the end of the whole select controls what order you see them in, right? So if you want them in a different order, you can actually do that. Right? There's two more functions that play along here. Dense rank works exactly like rank, except when you have ties, we're not going to skip numbers. Right? So Heminger and Lucchesi here are still tied at number 2. Thompson is now number 3. So we're answering sort of a different business question here, right? In the previous example, I would have said Thompson is the 4th highest paid employee, which I think is true. In this case, we're saying Thompson has the 3rd highest value for salary. Right? The data is the same. It's just, how are we treating the ties? Do we skip numbers for the ties or not? Right? That's rank versus dense rank. There's also a row number, which deals with ties in yet a completely different way, right? We have a tie with the 2nd value there still, but one of them is going to be 2 and the other one's going to be 3. So you have those 3 functions. They work almost identical to each other, but really the only difference between the 3 is how do they deal with tie values. That order by could be more specific, right? We could say order by salary descending, comma, bonus descending, meaning if we have a tie at salary, it'll be broken by the value for bonus, and you'll only have an actual tie if both of those numbers are the same. And so you can put whatever order by you want in that over clause. Okay. We can also use this to help us come up with percentiles. And this is a really neat little trick that we can pile on top of the stuff that we've just talked about. Okay, I want to know my rank within the data, or my percentile within the data, right? And it goes through an example of like GPAs, right? If you're ranked number 120 in your class of 600, you're in the top 20%, right? And it shows you how to do the math. Well, here we're just going to do that math in the SQL. So in this case, we're just using the rank function, or the dense rank function, right? So the first line in red there is just coming up with the rank. And then what is the next line? Well, we're doing the dense rank over order by salary ascending divided by 33. Now, if you look at the very top, it says that my employee table contains 33 employees. So I'm taking their rank and dividing it by 33. And then multiplying the whole thing by 100 to get the percentile. I have a little call out there just that notes that number 33, if you didn't want to hard code it because, the number of rows in the table might change over time, we could actually stick a subquery right there that just counted the rows, right? So that it would work in all cases. That would have made the text fall off the bottom of the slide here, and we like examples that fit on a slide. But if you're good with SQL, you could probably pretty easily add a couple lines, replace that number 33 with a subquery that counted the rows. Okay, and also down in the where clause, then it looks like we're putting this in a table expression. In the where clause, I say only want the people who are in the 95th percentile and above. One quick note on this: these OLAP functions, rank, dense rank, and row number, they are a little bit unique in that they can only be used in the select. Right? You can't stick them in a where clause. Well, you can see what we did right here to kind of manufacture putting them in a where clause. That percentile, I want to put that in the where clause. So what I did was wrapped the entire original query in a table expression. And now I've manufactured columns called rank and percentile that can be used anywhere. Right? So we've done a little bit more magic by putting that in a table expression. Right, and this is the result. Right, we only had a couple of people in the top 95%. But then if you look at the entire, without that where clause, essentially, everybody's percentile. You can see what we've done there. This is just the result of the query we wrote on the previous page. Okay. A couple other version 9 things, and then we'll move on to more modern releases. But these are things that not everybody knows about these, and they're pretty cool to be able to use. We have something called a row change timestamp, and all that is a timestamp column that's automatically updated by Db2 every time you update the row. Okay, so update timestamp is the name of the column. Timestamp, it's not null, generated always for each row on update as row change timestamp. So this is DBA work right here when they create the table. We have a lot of these update timestamps on pretty much every table I've ever built. Right, we want to know when was the row last updated and who updated it. So the update timestamp in this case is being automatically populated by Db2. That generated always just says, hey, you developer, you can't touch this column. Right? Db2 is going to maintain it. You can query it. You can see when the last time it was updated, but you can't put your own timestamp in there. Db2 is going to manage it. There was another one. So here's just an easy example of show me what's changed in the last 7 days. Right? A companion feature called the rid function, also introduced in version 9. You can actually select from the table, employee stuff like the employee number, last name, salary, and I can grab the rid of emp. In other words, if you have a join going on, you have to tell it which of the tables, right? And even if you don't have a join going on, it expects you to tell it which table you're talking about. We're the rid of the employee table. Select the rid of the employee table. And you get back this column called rid, in this case, 8708. It's actually a big integer. It's an 8-byte integer. The rid in Db2 terms is the physical address of a row. Now, you can't take a rid and stick it in your pocket and hope to come back to it next week, because rows do move, particularly when DBAs do things like reorgs, or if the data gets reloaded via utility. So you can't assume that a rid will never change, because they do change. But if I happen to know a row's rid, its address, it turns out it's super fast for Db2 to look it up. All right, Db2 can actually look it up much faster than by using its primary key. Right, if I said select where employee number equals 30 in this case, Db2 is going to probably use the primary key index. It's going to hop through the tree structure of that index. When it gets down to the leaf page level of the index, it's going to say, oh, employee number 30 is at location 8708, and then it'll go pull the row. In this case here, we're bypassing that. In my update statement, I'm saying, hey, just get me row 8708, or I want to update row 8708. Now again, I've got a pretty brief window when I can do this, right? Because that row won't always be located at that address. But like within a unit of work, say within a program, right? If I select a row and then I want to come back and update it milliseconds later maybe, this will be a really fast statement. That update where rid is equal to a particular value is going to be, it's called direct update, right? No indexes, no looking it up by its key, just go straight to that row and update it. Now, that's a little bit unsafe, right? Because as I've already said, the row can move. Now, it's not likely to move in the time it takes me to do that within a single unit of work. But if I want to be like super duper sure, I can combine that rid function with the row change timestamp that we looked at earlier. In other words, when I select the row, here where it looks like we're in COBOL doing a fetch, right? When I select the row, grab the rid and the row change timestamp. And then when I do an update, you say where the rid equals and the timestamp equals. So in other words, if the row has moved, right? Or if somebody else came along and updated the row while I was in the ... in the middle of the screen there, this update will give you a 100. Right? And then you can go into some process for reselecting the row or whatever you need to do. All right, this is called optimistic locking. What it means is you could actually do your cursor select at the top there, something like with UR, or certainly with cursor stability, and not hold on to the locks. For fetch only, it would be probably the most common way to do that. In other words, don't hold the locks while I'm in COBOL land there deciding what to do with the data. But when I come back, I'll do a direct row update and check the timestamp to make sure nobody else changed it. Neat little technique making use of some newer functions. Okay. There's several examples here of these moving aggregates using the OLAP expressions, just like we saw on the rank functions. This was a version 10 thing that said those OLAP specifications can be applied to any of the aggregate functions like sum, min, max, average, or count, although I have a harder time figuring out how it might be useful for count. But you can see what's going on here, I think, right? Selecting employee number, department number, salary, and sum of salaries over order by salary ascending rows unbounded preceding. So that's all a lot of words. But basically what I'm asking for there is a running total. And if you look at the result on the bottom there, I think you can see that. Right, lowest salaries at the top, 15,340. The sum of salaries to that point is 15,340. The next guy makes 15,9, and my running total is now up to 31,240. So that rows unbounded preceding is saying how far back do I go? I'm summing the salaries, the current one, with every row that preceded it, right? Unbounded all the way back to the top. So you can get a running total with a sum or a running average with an average. And that order by is going to be determine how the running total works. How about this? Now I've added a new thing to it, right? Partition by department number, order by salary, ascending. So now I have the partition by just says we want to do a control break at every new value for department number. Right? So I have all the A00s at the top, and then the running total for all the people who work in department A00. And if you notice on line 5 there, we changed departments to B01, and the running total starts over. And it starts over again on the very next line. This is called a moving aggregate, in this case a moving sum, right, where you're developing a window around the row that you're positioned on and applying some column function to that window. So this is a pretty neat feature that all kinds of uses for. I did a webinar a couple years ago. I think I did a series of 3 webinars, maybe it's probably been 2 or 3 years ago, on kind of advanced SQL topics where I spent a good bit of time on this feature. You can take a look for that in the webinar history that I talked about earlier. Time zone precision, this is another one that not a lot of people are aware of, came in version 10. The timestamp, as we've always known and loved it, looks something like this, right? This guy right here. Year dash month dash day dash hour dot minute dot second, and then fractions of the second down to the microsecond. And that is what we, standard Db2 timestamp, goes down to the microsecond. That is now what we'll refer to as a timestamp 6. And if you're, if you are still just going to use standard Db2 timestamps, we can just say it's a timestamp. The default kind of timestamp is now timestamp 6. The number 6 is how much precision to the right of the second. So I have 6 digits of precision to the right of the second there, timestamp 6. But in Db2 10 and after, we can actually have timestamps of 0 through 12. So timestamp 0 is no precision to the right of the second. A timestamp 12 is 12 digits of precision to the right of the second, or anything in between. So if you're, if you have a row updated timestamp on a table, and the only purpose of that timestamp is for a user to be able to look and see when a change happened, like a human, then timestamp 0 is probably fine, right? Just show me the second, and you'll save a little bit of storage, right? Every 2 digits of precision adds 1 byte to the actual storage needed, because these things are stored in packed decimal under the covers. And you can save a little bit of storage by just saying, what, if it's just a human looking at this, hours, minutes, and seconds is probably enough, right? Now, if you need to be able to sequence transactions or pieces of a transaction, using the machine, then more precision is probably good. If I need to say, that A happened before B happened before C, and they all happened in the same second, then more precision is good. And we can actually go up to timestamp 12, right? Timestamp 12 is 12 digits of precision to the right of the second. Okay, so you can be much more precise for things where you're actually counting on the machine to sequence events. We also have some time zone, and you can have a timestamp with time zone to put some context on it. So the time zones are always shown in offset to UTC. So the current time in Greenwich, England, right? London, essentially. So this one is running on a machine in New Jersey. So the offset to UTC there is -5. So 5 hours behind UTC. Okay. There's a section here on temporal tables. We don't really have a lot of time to do this justice. So I'll talk about it conceptually, and then you can look at the examples in the slides. When I teach this in real classes, we can spend hours or even the better part of a day on this if people are really into it. The whole idea with a temporal table, which was introduced in version 10 and was enhanced in both 11 and 12, is the idea that DB2 can be aware of the passage of time. And it can do that 2 ways. Right? We can have business temporal or system temporal. And I find the system temporal people tend to be, it's easier for us humans to understand. So the idea of a system temporal table is that we're keeping an audit trail. All right, and you can automate it and let DB2 keep track of it for you. So every time I do an update or delete on a system temporal table, DB2 will automatically track what the row used to look like and when did it look like that. And the when is tracked by those last 3 columns on the table here that are all defined as timestamp 12. And that is when did the row start looking this way and when did it stop looking this way. Okay. Now, there's also a history table that sits behind this to make all of this work. And basically, you're asking DB2 to automatically keep track of the history of a row using this history table. It does allow us to do some pretty cool things. This is the alter that makes it happen. But I can say something like, hey, select from my table for system time as of and stick a timestamp in there. So on January 30th of 2018 at 1:46 in the afternoon, I want to run this query and I want it to return the data to me as if I had run the query, what, a year and a half ago? And DB2 will actually recreate the data as it looked then because we're keeping track of the history. So that from clause extension there for system time as of, or the second example, you can give it a range of time, right? It will recreate the rows as they looked at that given time. And that's pretty cool. Now, behind the scenes, it's actually generating a big union of the base table to the history table with a bunch of timestamp logic in each to help figure it out. But it's it's what some people have referred to as the time travel query. Another thing that, and this is a version 11 feature, global variables. This is a feature that I haven't seen applications using very much, but I'm seeing IBM use it all over the place. So a global variable, it's just a variable that lives in DB2 and not in your program, right? So if we create a global variable, in this case, I've created a global variable the DBA has called GV timestamp, and they grant privileges to it. With SQL now, I can say, hey, set GV timestamp equal to, and I'm giving it a value, a timestamp value. So the definition of the variable lives in DB2 in a catalog table. But if you and I both use this variable, we'll have our own copy of it. So in that sense, they work a little bit like temporary tables. Okay, the definition of the variable is, is shared. It's called GV timestamp and it's a timestamp, but the actual data is not shared. And it just allows you to do what you can do with variables, right? So I can actually in a select statement say select where a timestamp is less than that global variable. It's just a variable stored in DB2 instead of in your application program. Now, what these things are more often used for than applications is by IBM to support features. And one of those features is transparent archiving. You can think of transparent archiving a little bit like you think of the temporal table, system temporal. But transparent archiving is quite a bit simpler. It just deals with what happens when I delete a row from a table. Do I really want to throw it away, or do I want to keep it off to the side somewhere? Okay, so that's what transparent archiving is. So quick example, I've got a customer table here, none of those weird timestamps that I needed for temporal. I'm creating an archive table just like the base table, and I'm altering it to enable the archive. Okay. Now, when I do a delete, DB2 is going to look at the values for these two special register, or not special registers, these are global variables. So the global variables that I talked about a minute ago, as I said, IBM is using these in place of what we might used to use special registers for. So there's two IBM supplied global variables called sysIBM_atom.move to archive or sysIBM.atom.get archive that control the behavior of these tables that are enabled for transparent archiving. So if I have sysIBM_atom move to archive set to a yes, and then I do a delete on an archive-enabled table, DB2 will automatically copy the deleted row to the archive rather than straight up delete it. Okay. There's some talk at the bottom there about these both initially defaulted to no. In version 12, we get a zparm that will help me control the default, and that zparm I think was retrofitted back into version 11 via an APAR. Okay. So this is something that's been interesting to a lot of people because we do this other ways right now, right? We have other ways for accomplishing the same thing. I think what I'll wrap up with is a related topic, and that is deleting data, and deleting data in a way that is friendly. So I was at a client recently, and their DBAs had made a rule. If you're going to do data modification in a program, you have to commit every 500 things. In other words, they can't touch more than 500 rows without doing a commit. It's a pretty good rule. All kinds of things, bad things can happen when you do too much between commits, right? You're holding locks. If you end up rolling back, that rollback could be quite large if you've done too much. So the idea that we should be committing frequently is a good one. Now, if you have a purge process, say, or somebody comes to you and says, hey, I've got 1 million rows that need to be deleted from a table, the discussion can ensue, right? How do we deal with that? Probably the best way, if you can swing it, is to have the DBA do a reorg with a discard logic. In other words, as it's unloading and reloading the rows in the reorg, it just discards the ones you don't want. And usually it'll put those, or it will always put those in a discard file so that they still exist, just not on the table anymore. We can do delete statements, right? SQL deletes, partition rotation, that's a whole weird, you'd have to architect for that. But typically we have are we going to do SQL deletes or utility deletes? And if I'm going to do SQL deletes, how do I do that without doing too much? So in other words, if I could come up with, let's say that delete statement at the bottom deleted everything that I wanted to, right? Where order date is older than, the oldest one we want to keep. And let's say that identifies 1 million rows. Well, my DBAs are going to get mad at me if I try and do more than a couple of hundred. And there's no way to stick deletes or commits inside of a single delete statement, right? I won't have the opportunity to commit until it comes all the way back. So version 12 introduces what they call a piecewise delete. Piecewise delete just says it's going to take that fetch first syntax that came from the select statement and allow you to apply it to a delete. So here I'm doing a normal delete with the where clause, and I say fetch first 5,000 rows only. It says only delete the first 5,000 rows that it finds that meet that criteria, and then take a commit. If I have 1 million rows to delete and I want to do it 5,000 at a time, well, what I'm going to end up doing is just run this same statement a bunch of times until we're done, right? But it allows you to limit the scope of the delete, and the main reason you would do this is to try and avoid doing too much without a commit. And I think the next couple of pages have, here's a native stored procedure that's going to do it, right? They code up the delete. They keep doing it until the SQL code comes back as a 100. Okay, that's in SQL PL native stored procedure language. Here's COBOL, right? Perform until no more rows. Do the deletes. Here we're doing the fetch first with we're parameterizing it with a host variable so that you could adjust it. Doing a commit after each one, and then keep looping until you're done. Okay. They call that piecewise delete, and that's a feature of version 12. All right, so that is the Dave's favorite of Tony's favorite things. I've left Tony's, for those of you who weren't here right at the beginning, Tony couldn't join us today because of a travel snafu. So you got me instead. But I'm going to leave Tony's email address up there because if you have questions about this, you can email Tony or you can email me. Again, the slides are on the Themis website, so themisinc.com/webinars. Or if you go to the Themis website, there's a tab at the top for webinars, and you can grab the slides from today's presentation. You can feel free, both of our emails are in that presentation. You can feel free to email either me or Tony if you have any questions or comments or feedback for us. Ideas for future webinars are also appreciated. So if you got something that you think can be dealt with in under an hour and are just curious about or would like our thoughts on, throw it out there. We'll consider any topics that come in. Thanks for joining us today. Hope you have a great rest of your afternoon, and look forward to seeing you in future webinars or classes. Thanks.